Hi, my name is Matthew Gray, and I'm in my final year of study pursuing a double degree of mechanical engineering and medical science. My capstone project is the biomimetic design of smart memory clothing for posture rehabilitation and exercise therapy. I've always been fascinated with biomimetics, that being the copycat technique of imitating biological processes and entities with man-made innovations to create sustainable solutions to human challenges. And what's a bigger human challenge than posture and rehabilitation? If you've ever been to a physiotherapist, you've probably heard something along the lines of, go home, practice these exercises every day, and I'll see you again in 3 months. But how can we actually track what happens in those 3 months? As we know from current literature, a major concern for rehabilitative training is the repetitive practicing of incorrect movements at home when corrective guidance is unavailable. Through repetition, muscle memory of harmful habits can develop, and these exercises can actually become counterproductive. On top of this, if the body is already vulnerable, as is often the case with rehabilitative patients, unsupervised exercises performed inaccurately can actually have detrimental impacts. So with this in mind, I set out to explore, design, and validate a commercially viable smart device that can be used to monitor and assist postural rehabilitation specifically for patients at home in the absence of a physiotherapist or a professional. This affordable assistive solution will improve patient compliance with and accuracy of at-home exercises, will reduce risk of injury, and will improve patient outcome by ensuring maximum rehabilitation potential is safely achieved. For my Explore objective, I decided to conduct a literature review. However, I was challenged in sorting through the sheer abundance of literature available surrounding posture and rehabilitation. To narrow this down and dissect the issue at hand, I decided to categorize my literature review into 3 sections: clinical relevance of posture restoration, evidence surrounding patient compliance with unsupervised exercises, and current at-home rehab devices. In doing so, I discovered a number of clinical examples for which posture rehabilitation is vital. Some examples being patients recovering from spinal surgery and mastectomies, and elderly individuals with hyperkyphosis. I found high rates of non-compliance with at-home exercises, with some studies quoting up to 50%. And finally, when comparing non-physical to physical training methods used by current at-home assistive solutions, I discovered that real-time physical feedback is the best method for at-home therapy. During my design stage, I faced another challenge. As a mechanical engineering student with medical science training, coding is not my forte, and it was certainly a difficult process to learn and implement the skill. However, I am very fortunate to have a talented and generous support network who helped me achieve this, and I can now proudly say that I'm quite confident with coding. Finally, my biggest challenge has been navigating my way through the volatile climate of COVID-19. It's forced me to pivot and shift my project in a number of ways. However, luckily for me, it's also given me some of my biggest breakthroughs. You see, before lockdown, my project was a little different. Originally, I was going to be following up on another student's project in developing a functioning arm sleeve that could reflect movements of deflection and rotation. This was to be verified with a universal robotic arm. However, due to resource limitations and restrictions, I could not continue with this project. This led me to my aha moment. I was inspired by the arm sleeve, but was limited in my ability to validate any sort of design with multiple joint movements. I thought to myself, how can I reliably and ethically replicate rehabilitative motions without advanced robotics? I realized that I could translate the methodology into a functioning posture device and validate it with a mechanical cantilever that I could build at home. Thus, my new project was born. What makes something innovative? Innovation is born out of a passion to deliver something different, unique, and something that also awakens others' inspirations and interests. This quote really resonates with me and my project. From the lightweight compartment-based design to the inbuilt personalized exercise program, this novel device is unlike anything else on the market. It is truly revolutionary, with benefits towards preemptive and rehabilitative intervention. To make my design unique, it needed to meet a number of evaluation criteria. It needed to be compact, comfortable, and easily adjustable. It needs to provide real-time feedback through a non-harmful physical stimulus whilst monitoring angular rotation in 3 axes. All of these were met. Through my research, I've seen multiple attempts at non-physical and physical therapy solutions, but none are able to provide the real-time vibrotactile feedback for posture management. Additionally, I've seen some mechanical posture devices on the market, but they lack the adjustability, technology, and personalization that makes this device unique for rehab. Electronic comparisons on the market are designed as posture reminders for healthy people and are not appropriate in the context of rehabilitation. They are not suitable for complicated exercises in 3 axes as they only monitor 1 axis and are not able to be personalized to a specific exercise program. My device fills this gap in the market. First and foremost, this product is incredibly marketable. You don't need to be a rehabilitating patient to benefit from the device. Anyone can use it to help fix or remind them of good posture. But a device like this that is designed specifically for rehabilitation is hard to come by. This innovative device will improve recovery efficiencies, cost effectiveness, and most importantly, patient quality of life, which is a pretty easy selling point. The cost of the prototype, including electronic components and 3D printing, was no more than $35. So when the cost of a recurring physiotherapist appointment can go upwards of $150, the affordability is really a no-brainer. The programming can be easily changed and personalized to match the recipient's capabilities and limitations. So when you buy this product, you are truly buying something that is designed for you. The proof of concept invention consists of 3 electronic components: an Arduino Nano, an integrated motion sensor, and a vibration motor to provide vibrotactile feedback. I also designed and 3D printed a components tray and external housing to hold the electronics. A Velcro strap was then looped through so that the device can be easily put on, held safely against the user's spine or neck, and easily adjusted when necessary. C++ code was also developed to instruct the device to gently vibrate when it is tilted at angles greater than desired for a number of different spinal and neck exercises. To validate the invention, the device was placed on a mobile arm that I built and slowly tilted towards the limiting angles to reflect leaning, twisting, and side bending. Visually, for the sake of the experiment, the vibration motor was replaced with 2 light-emitting diodes. When the angle was in the acceptable zone, the green light would turn on. But when the device was tilted at an angle greater than desired, the red light would turn on. I then compared these theoretical results on the code script with the actual angles found when using a digital protractor. The test gave very promising results of real-time accuracy, precision, and minimal movement discrepancies, showing that the invention was successful. In my project, I listed exercises that may be relevant to the end user, as well as maximum movement recommendations. This opens the door for various exercises to be assimilated into the code of the program, even with the possibility of including gradually increasing levels of difficulty. The long-term goal of this product is to be integrated into a family of smart memory clothing that have similar intended purposes as this device, but for other focal areas of the body, such as the arm sleeve that I mentioned earlier. Under the brand IntelliClothe, these products will work harmoniously to ensure that the user can perform any rehabilitative exercise in the comfort of their own home without the fear of doing something wrong or harmful. We also plan to develop a smartphone or watch app to control the clothes and choose the program. I hope that you consider my project for the Allen Chappell Award for Innovation. Thank you very much for watching.